Hello and welcome back for the second part of our program, the roundtable discussion. Joining me, Jean Tonalty and Susan Schneider, both mothers of children with epilepsy and members of Citizens United for Research in Epilepsy, or CURE. Jean is the mother of Christopher Tonalty, the young man for whom our very first award in epilepsy was named after he died from sudden unexplained death in epilepsy, or SUDEP, at the age of 21. Susan Schneider is the mother of Julie, who started having seizures when she was 3 years old and ended up, after going through an exhaustive list of drugs, having 3 consecutive brain surgeries before she found partial relief from her condition. Susan has had various roles with CURE in the past, including helping with fundraisers and reaching out to families who contact the office. Thank you very much for being here, and thank you for your support all those years ago that got Jenna and I started. Could you say a little bit about your role at CURE?
My role there now, I'm on the board of directors. I've been on the board, I believe, since 2003. So the responsibilities that go along with a board member. We also do a fundraiser every other year in Utica, New York, where we live, in Christopher's memory. And I think it was our second fundraiser that funded your part of your project. And I also, through CURE, have a mission to try and convince physicians that they should tell their patients about sudden unexplained death and epilepsy. So CURE has given me a platform to try and change that protocol, that policy for physicians. So that's what I do.
Susan?
I am a parent volunteer with CURE, and I have been for about 8 years. I became aware of CURE and called and started speaking to Susan Axelrod about our situation with our daughter, and it was just a natural progression of becoming involved.
So there's a number of different organizations that fund research in epilepsy and epilepsy advocacy. What would you say distinguishes CURE's role from that of, say, the Epilepsy Foundation or some of the federal agencies and so on? What is unique about CURE's mission?
CURE, from the very beginning's mission was to raise, twofold, to raise funds and to promote awareness.
One of the things about CURE that we're very proud of is that we've received a 4-star ranking from Charity Navigator, and 95 cents of every dollar goes directly to research. And that was very appealing to us, obviously, because of the importance of research.
When you raise the funds for a research project like the one that we've been describing tonight, and then you come back after all these years and you see where we've gone, what sort of an impact does that have?
When we're able to raise money and to support a project like yours and to listen to your presentation tonight, it's very comforting to us, very gratifying, and it really gives families hope. It's too late for Christopher, but it's very important to us that other families have hope that with research and with new technologies, that epilepsy, we're moving closer to a cure. So it's very gratifying.
And is this sort of research different, you think, or different in its focus from the majority of what you see being funded or reported on?
Well, CURE just commissioned and did a report on the state of research, epilepsy research, and found that 3/4 of the research being done is on new drugs. And as we learned in your presentation, a third, 30 to 40% of the population are not responsive to drugs. So it's very important to us that other types of research, particularly in technology, are being pursued.
Now, you mentioned earlier when we were having lunch today that the mortality rate for epilepsy, I think you said at 40,000 annually, was higher than it is for breast cancer.
That's correct.
And yet, the amount of publicity that gets is significant compared to breast cancer. Why do you suppose that is?
I think that there is a hesitancy on many people's part to speak out about their epilepsy. There's still a stigma attached to epilepsy, and to some degree, people are still hiding it.
Now, we also talked about the different sorts of treatments that are available for patients with epilepsy, with drugs and devices. Now, you have a personal experience with surgery. Could you tell us a little bit about that?
Julie had her first surgery after trying many different drug combinations. Her first surgery was a small localized surgery, and we were very hopeful that she would be helped by that. 6 months later, she was again having seizures. The only difference was they were much more severe than they had been before. Finally, 3 years later, it was recommended to us that she have an extreme type of surgery called a hemispherectomy, where the affected side of her brain, which she had a large cortical malformation on the surface of her brain, not the surface, but on the cortex. They basically severed the connection and cutting off the seizure activity. The seizure activity remained on that side, but it was severed and it couldn't transfer over to the other side. The price for that surgery was very dear. It cost her basically the right side of her body. She came out of it almost as if she'd had a stroke. And she had to learn how to walk again. She walks with a limp. She lost the use of one arm and one hand. She's blind in one side of each eye. She began drooling profusely. Her speech was very disturbed. And she lost bowel and bladder control. With a lot of therapy, she has regained some of those things, but she still does not have use of her arm and her hand. And then 6 months later, the seizures came back. So we again tried drug treatments, and a couple of years later after that, she had another hemispherectomy surgery that severed the connection just a little bit more. And so far, that is holding off on the seizures. We are always in fear, though, that there could be a focus on the other side of her brain. So you're never complacent. So she paid a very high price. And the truth is, we would do it again.
Now, beyond the research, is there an advocacy role that you can do? Is there an advocacy role that Cure has to get that mission statement out, not just to the public, but also at the legislative level?
Cure does quite a bit of advocacy with the federal government, with NIH, seeking to increase the federal funding on a federal level for epilepsy.
Now, Cure is headquartered in Chicago, right?
Correct.
Now, is everybody affiliated with Cure in Chicago?
No, I'm from upstate New York. We have another board member from Rhode Island. We don't have chapters in other areas. All of the administrative work is done out of Chicago, and that's really to keep our costs down and so that our money can go to research. And so Cure is run out of Chicago, but has support all over the country.
Can you give us a sense of how much Cure has grown over the last few years? How big are you now?
In the 10 or 11 years it's been in existence, we've raised $10 million and funded 85, I believe, cutting-edge research grants. And people are hearing from it. There was a piece about Cure on 60 Minutes, and so that generated a lot of interest on our website and donations. So we are growing.
Another really important thing that Cure does is it helps to put on conferences and forums for scientists such as yourself to bring people together for collaboration and idea exchange.
Now, do you usually stay in contact with all of your prior fund recipients?
I think Cure makes a real effort to do that. We work very hard to raise money, and we consider people who we've funded to be part of the CURE family. So we make an effort to keep in contact with everybody, and I think we do a pretty good job.
So for the folks here tonight, listening to the stories of the patients and the research, and listening to you here now, as they leave here, what can they do to become involved? What is the most important thing that they can do to impact epilepsy research?
We would like everyone to spread our stories. I mean, we are all about telling our stories to put a human face on this devastating disease. We want people to take away an awareness of what it really is to live with epilepsy.
Thank you. Thank you very much, and thank you for your time. At this point, I'd like to open the discussion up to questions from the audience, but before I do that, I'd like to introduce another very special guest that we have here tonight, Sandy Staccaro. Sandy, if I could ask you to stand up real quick, just so everybody can see you. Sorry to put you on the spot. It's a terrible thing to do. Sandy is the mother of Amanda. Thank you very much. And thank you for being here. Amanda, the last of the 5 stories that you heard at the prologue video this evening. Thank you for being here. Thank you for joining us. And thank you also for sharing your story. So, questions to any of us on any subject?
Can you explain to me the difference between the technology that you are researching and the VNS, or the vagal nerve stimulator? I understand how you explain the difference in the can, basically, which is the surrounding area for the VNS when it's implanted. But how does the difference of that stimulator possibly being in the deep brain tissue versus wrapped around the vagal nerve, sensing seizure activity as well, if you could briefly?
That's excellent. So the vagal nerve stimulator is the only FDA-approved implantable device for epilepsy currently. It's developed by Cyberonics, the same company that funds a lot of the research that we do in our lab, and it's had a tremendous impact on a large number of patients. There are some key differences, however, with the work that we're talking about here tonight. The first of which is with regards to its being responsive. The work that we're trying to do is to stimulate only when a seizure is about to begin or has already begun, and not continuously. And the reason for that is that by stimulating less often, you reduce the probability that the brain or the body will become accustomed to the stimulus and will begin to ignore it, just like with drug desensitization. The vagal nerve stimulator is not responsive. It stimulates all the time. So that's one difference. Another difference is that the vagal nerve stimulator is a much lower risk device, in the sense that it is connected to the vagal nerve, one of the cranial nerves, but external to the central nervous system. And so there is no brain surgery associated with its implantation. The advantage of that, of course, is the lower risk of infection, lower risk of complications, and so on. The disadvantage is that the seizures begin always in the brain. And so by positioning a device externally to the brain, you're operating at one remove from the focal area of the seizure. So the hope is that because the vagal nerve travels to the brain, and the areas of the brain to which it projects are adjacent to, or in some cases identical to, what the epileptic focal area is, that stimulating the vagal nerve will be a proxy for stimulating the brain directly. And to some extent, and for many patients, it works just that way. But for some patients, indeed quite a few patients, it doesn't work that way. And so the sense is that by identifying the brain structure, even though it's higher risk, the ultimate efficacy of the device can be dramatically higher than for a vagal nerve stimulator, especially when coupled with a responsive nerve stimulation.
I have 2 questions, one for Cure and one for Pedro. For Cure, can you describe 1 or 2 of your biggest other research successes besides Pedro and Jenna? And then for Pedro, can you describe in a little more detail your neurotransmitter research and how you see that working with your electrode research?
I can speak to another grant that we funded through our efforts in Christopher's memory, and it's at Baylor University, and it's actually on the CURE website. It's in Dr. Noble's lab, and it actually has to do with SUDEP. And I'm not a scientist, but they have discovered a gene that is present in patients who die from sudden cardiac death. And they believe, and I hope I'm getting this right, that it's also in the brain. And so they're very excited about that. And it's a real success story for Cure. One of the doctors in Dr. Noble's lab, Alicia Goldman, won a Cure grant. And part of the work that she has done on this project has contributed to this outcome.
And to answer your second question, with regards to the neurotransmitters, the problem is that when we electrically stimulate, we don't really know what it is we're doing. We can blast enough juice in there to stop a seizure, but we don't know what the secondary effects are or even what the direct effects are. One reason is because if we electrically stimulate, we're not able to simultaneously electrically record to see what we're doing to the cells because the stimulus saturates the recording amplifiers. Those amplifiers are so sensitive that the magnitude of the stimulus, which is 1,000 times greater than what we're trying to pick up, basically destroys our ability to record. So one thing we're trying to do is develop optical stimulators, one of which I showed, that will allow genetically modified mice with channel rhodopsin to respond to light. So we can stimulate with light and then record the electrical activity simultaneously. If at the same time that we do that, we can use some of the technology, some of the microelectrodes that Jenna has developed to monitor individual neuronal release profiles for two key neurotransmitters, GABA, which is the primary inhibitory neurotransmitter of the brain, and glutamate, which is the primary excitatory neurotransmitter of the brain. If we can monitor those and then correlate that at the neuronal level, then the hope, and it's a hope, the hope is that we'll be able to understand the neuronal circuitry underlying the mechanisms of epilepsy better, and in that way get some sort of an insight as to why a particular type of stimulus works to stop a seizure, and how can we optimize so that we can deliver the maximum therapeutic benefit with the minimum amount of invasiveness.
Just one other point on the serotonin. I don't want to leave out Dr. Carl Feingold at Southern Illinois University, who's also doing work in that area, and really he also received a Cure grant and was the first one to get it for that particular issue. And many of you may have heard, it was a couple weeks ago, that there have been some promising findings with serotonin levels in the cause of sudden infant death syndrome. So it's just interesting because there's some commonality between the two. That they're finding that with SIDS also.
I'm wondering about how the Weldon School of Biomedical Engineering interacts with the other disciplines that are involved in this research.
So biomedical engineering in general is a very multidisciplinary area of research from its inception. My background is my bachelor's and my master's degree in electrical engineering. Some of the folks I work with have similar backgrounds in electrical engineering, some in biology, some in neuroscience, some in chemistry, some in mechanical engineering, some in material science engineering. And at the end of the day, you're bringing folks from a wide variety of disciplines, each of whom has the expertise on, say, the materials that make up the package, or the electromagnetic waves that are going to be used to power the implanted device, or the semiconductor physics that's going to be used to design the microchips, or maybe the neurotransmitter function and release in the neuroanatomy of the brain, or maybe the development of the correct animal model, or the physician who's going to come up from IU School of Medicine, Dr. Worth comes up often, who's going to help us look at these local field potentials and say, look, here's where a seizure starts and here's where it stops, here's what makes it a seizure, here's the kind of things that you're looking for. And these sorts of projects where you're trying to deliver a complete system solution to a problem as complex as epilepsy are far beyond the capabilities of any one individual with any one traditional branch of training. So in order to attack these, really there's no other way to go about it but then to come at it with these multidisciplinary approaches. And it's not just us, the faculty, that are multidisciplinary. If you come into our labs, you'll find undergraduate students, graduate students, and PhD postdoc students with all sorts of different training from all sorts more traditional disciplines. That's really the only way this kind of research gets done.
Is there a collaboration between the Cure Foundation and the Epilepsy Foundation of America? And if not, then what's the difference in terms of the motivation, the target, what exactly each foundation is targeting and looking to fund?
Really, our mission is research. And the foundation, as Susan alluded to before, is getting into some research, but they're more of an advocacy, patient advocacy, job discrimination. They run camps, so it's kind of,
Support, education, community education. Their missions are really quite different.
This question is for Jean. Jean, one of the astounding things that I found out through having a child go through epilepsy and losing their life eventually was all of the staggering statistics and numbers. And I couldn't understand for the life of me why people don't know these things. Why people don't know that more people die from epilepsy in our country than breast cancer. And an interesting study that I had read done in 2005 said that people were more apt to tell you they had HIV than epilepsy because of the stigmatism. What, in your words, do you think are some of the obstacles of getting that information out there? Is it a case of marketing, having a Susan G. Komen issue where there is that person pushing? One of the things about Cure is that it was moms that came together. It was people that had a valid interest and a personal interest in fighting that disease. Is that what it takes as far as the only thing able to push that forward, or are there other obstacles that you see that can be overcome in some other way?
When Christopher was diagnosed with epilepsy, right before his senior year in college, his doctor, his pediatrician, told us to tell him not to tell anyone. So, and I don't think that that's uncommon, and I don't know the reason for that. I mean, I don't know why you would tell a child that, or a young man that. Certainly if it was another disease, I don't believe that the doctor would have said that, and I don't know the reason. I don't know if it's the historical stigma of epilepsy, an embarrassment when somebody has a seizure. I think, unlike cancer, breast cancer, there is not a famous person, so to speak, who has been willing to come out and lend their name and support to helping people understand the disease. You know, I don't know. I think there's just many reasons, and it's very sad, and I think Cure is working hard to change that, to make it okay to say that you have epilepsy and that someone in your family has it. And I think that's how everybody here can be helpful.
Do you see any different challenges with adult epileptics, either in terms of education or research? So all of the stories that we heard initially were concerned with pediatric epilepsy, but do you see, in terms of advocating for the problem or in terms of research of the problem, do you see different challenges that would be involved in looking at adult epilepsy?
I think the Cure does look at, you can speak to this better, Jean, than I, research projects relating to adults. But also, Cure has been funding research focusing on traumatic brain injuries with our returning veterans who are surviving head injuries that in past times they probably would not have survived, and the chances of them having a seizure disorder after sustaining these injuries is very great. Even for our own selves and the elderly, elderly patients are living longer. Elderly people, not patients. They're surviving things like strokes and heart disease. Alzheimer's is associated with seizures. Other neurological syndromes. So yeah, there's.
I think when Cure started out, the moms that started Cure, they had young children, and those children now are growing. And although we do fund a lot of research that has to do with children, we would also consider proposals for very possibly Alzheimer's patients, stroke patients. As Susan mentioned, we have a targeted research program for traumatic brain injury. So, yes.
Can you tell me then, your best conditions, best happenings for your research is that it goes to clinical and it becomes approved. Would it be for partial seizures only, where there's a focal that can be identified, or would it actually work for generalized seizures when they can't identify a focal point in the brain?
Another excellent question. So there's many different kinds of seizures. We always see on television and in ER and so on grand mal seizures with all the characteristic symptoms. But there's a number of different kinds. The distinction here is between partial seizures, where a seizure begins in a focal area of the brain, and a generalized seizure where it begins throughout the brain simultaneously. These devices would not be for generalized seizures. However, they would be for a third category, which is called partial seizures with secondary generalization, where they begin in a focal area and then spread to the brain. And those are overwhelmingly represented amongst the same patient population that is non-responsive to drugs. So really, it's those patients that we go for. But you're absolutely right. Many patients do not have seizures that begin focally, and when the seizures don't begin focally, the magnitude of the electrical stimulation that might be required to stop the seizure if it begins in a generalized state might be such that this device will not apply to those patients. But our goal, to get to your first question, is to have a clinical impact in a patient. If at the end of my career, I can look at a single one of these kids and know that because of the research that we're doing here at Purdue, their life has been changed for the better, that they did not end up with the brain damage that they might have ended up with, that they did not die from sudden unexplained death from epilepsy because of the work that we did here, then I will consider my career to have been a success. Once again, thank you all for your questions and for coming here tonight. Thank you especially, Jean and Susan, for coming and telling us your story and representing CURE. And thank you, Sandy, for coming and sharing Amanda's story as well. Thank you, and good night.